Welcome to the Got Academy podcast. Hi, everybody. Hi, Mitchell. How are you doing, Mitchell?
I'm doing good. How are you doing, Gil?
I'm doing very well. We have been going back and forth thinking about what will our Gotributor conversation be about. And then, boom, you had this idea that combines your area of expertise and a new angle that we haven't discussed yet.
Yes, I was initially quite worried, actually. I watched the first Gotributor podcast with Mallory, very unique sort of cool take on things with the linguistics angle. And I was very worried because my background is in, I've done degrees in computer science and actuarial studies. And I was thinking, okay, well, Westeros doesn't have a lot of computers. It doesn't seem to have a lot of insurance either. Probably be pretty insane to be a life insurer in Westeros. You'd go bankrupt pretty quick. Hit me. I was thinking, well, actually, I've got a background sort of doing data analysis. There's surely some data, some Game of Thrones data out there that's being used. And I did a quick Google search, and lo and behold, there's actually a lot of very cool sort of data science projects.
And especially in anticipation to season 8, I saw some articles about that.
There's a lot of prediction models out there and all predicting sort of who's going to die next. There was one in particular I was looking at, which I think seems to be the one with the most buzz, which is by the Technical University of Munich. And so they've put together their model using machine learning and neural networks to not just figure out, if a character is going to die or not, but they've got the predicted likelihood of death, or PLOD. So they've got a percentage number, and they don't just have percentage numbers per character. If you go onto their website and you click on a character, you'll actually see they've got how likely they are to survive every particular year. They've gone into a lot of detail. You can go to their website, which is got.show, which I'm surprised HBO didn't already take that one.
Got.show, that's it?
Yeah. So got.show. It's very, very cool. Yeah, decoding Game of Thrones, data science in Westeros. So this is a very cool overview of a lot of different projects that are going on. And when I first read it, I had a bit of a laugh because this was written in April this year when season 8 was still underway. So they hadn't finished the season yet. And they mostly kind of judged the model based on its performance in 2016. I'm going to read out one little passage here which made me laugh. In 2016, it did a pretty stellar job. For example, it correctly predicted a high PLOD for Tommen Baratheon, 97%, Stannis Baratheon, 96%, and Peter Baelish, 91%. However, it was not entirely accurate. It also predicted that Daenerys Targaryen had a 95% chance of dying. They only had season 7 to go by back then. And the bit that makes me laugh is they say that obviously that was wrong.
And now I'm looking at got.show, and they gave her a 1% chance of death.
Yes.
And I remember reading all kinds of machine learning AI things about who's gonna live, who's gonna die in season 8, and I was like, is this the part where humans still are stronger and better than computers? So chess players, boom, you're out. All kinds of doctors, you're soon out. But YouTube channels with predictions, ooh. I think they had Sansa likelihood of death like at 70%. Maybe it's not them, maybe it's a similar thing.
Yeah, around there.
Okay.
I am going to get a bit into that actually, who's better in this particular field. But yeah, it made me laugh a lot that, they gave her a 95% chance of dying. She didn't die in season 7 and they said, ooh, we weren't right. So they adjusted it so heavily that she then had a 1% chance of dying, which obviously in season 8, that was wrong. Basically all models that were predicting this, to be honest, they were kind of doomed from the beginning. The people behind this one, I'm sure they're very smart people who are very experienced at what they do. But when you're using machine learning, what you're essentially doing is you're looking for patterns that exist in past data, and you're assuming that those are going to persist and just stay the same. And, when you're, for example, trying to predict cancer in early stages by looking for other symptoms that are, highly correlated but that aren't immediately obvious, this is a very good thing, and it often turns out that these patterns persist, and that's a good thing for us. But when you're talking about a story and how a story unfolds, it would really be quite boring if patterns just kept going the same way. Saying, okay, the Lannisters are doing well and the Starks are doing not so well. If that just kept going through the entire show and never changed, that would be a very boring story. You can actually look at it and see in particular they gave a very low chance of death to Daenerys, but also to Cersei. Like, you're looking at it as a human. These two are on a collision course. There obviously wasn't going to be both surviving. They're not going to survive the fight with the dead, then reconcile their differences and go live happily ever after.
Yeah, they should have put the data that they should have put in is stories. Like they have to understand stories. Also, I see that Jaime had like 4% chance of dying. And Brienne, 13%. No, and I was like, Brienne was never going to die because if you understand the story, you see where each character peaks, and from there you can maybe understand what is their role in the story, what are they supposed to do in the story, have they accomplished this feat yet? And Brienne was supposed to become a knight, a Queen's Guard, King's Guard, whatever. If she were going to die before that, that would have been just like useless. What was that character all about?
So that's exactly right. There's a lot of things that these kind of models obviously aren't taking into account. They aren't looking at story structures and, making logical decisions based on all sorts of other factors. I had a look at how they built the model, and they were using factors like whether somebody was a noble, whether they were a male or female, what house they belonged to. There's obviously so much missing there in how a narrative is going to unfold, and the fact that certain people are going to be going up against each other and only one can win. We theoretically could reach a point where a model takes into account all these things and they're sort of put into a language that machines can understand. Maybe they do outpredict us, but certainly for now, this is humans' domain.
Wow, this is so. Yeah, I found Sansa 73% and Bran 58%. Theon 10%.
Yeah. Though it has to be said, with 58%, as you get closer to 50%, if you put it at 50%, that's essentially you saying, I have no idea. Could go either way. A lot of people don't seem to kind of get that. I noticed this in particular in the 2016 US election. I'm not going to get into any of the politics of it, but I remember I was watching some of the statistical models. I was following in particular 538. They're a statistical modeling firm who had the chances of, Donald Trump winning or Hillary Clinton winning. And I remember they gave Trump on the final night a 28% chance that he'd win.
Which was the best chance that he got out of all of the predictions out there.
Yeah, I remember Huffington Post gave a 5% and kind of made fun of 538, and they got egg on their face later. But afterwards, 28%, people need to understand that that's a very significant percentage. In that sense, that says that this definitely could happen. But afterwards, when Trump won, there were people targeting 538 specifically, saying, haha, you were wrong. And it's like, if you have two coins and you flip both, there's a 25% chance that both will be heads. If you do that right now and you get two heads, you're not going to turn around and laugh at me and say, haha, you were wrong, this happened. It's not how probability works. And there was one particular Twitter exchange I saw that just kind of broke my heart. Because somebody was saying, haha, you were wrong. And somebody came back and said, well, no, they gave Trump about a 30% chance. And this person came back and said, oh, so they were 70% wrong. That's not how this works.
Yeah, it's not. But it does feel that way when I see Sansa Stark. 73% for me, it's like 100%. I'm like, if you say that Sansa Stark has 73% of dying, then you said she was going to die, then you are wrong.
This is actually a whole theory of study. It's called prospect theory, and it deals with, when it comes to sort of gambles, people really overweight low probabilities and underweight high ones. So when people are, buying a ticket for the lottery, the chances of you winning the lottery are so incredibly slim, but we just can't actually fathom that level of, lowness. We see it more as if it was maybe a 2% chance when it's nowhere near that.
When the odds are in our favor, then we think that they are much more in our favor. We like oversample whatever.
Yes.
I just saw, by the way, that Arya had a 43% chance or 47% chance.
Yeah.
Ay.
One of the ones that I think is quite interesting out of the probabilities actually is Bronn, I think, had like a 94% chance or something. That's one where I feel like they were probably pretty spot on if we're going by the books. But I think George R.R. Martin had that whole talk of Q ratings and, Bronn gets the audience going so they keep him around.
Yeah, actually I thought it was going to die. I can gloat on that one. But it really feels to me like really misunderstanding not only this story, but stories. Kyborg.
Yeah.
6%. What kind of role would he have? And as you said, right, Cersei and Daenerys. This was your first example. How can they both stay alive? What kind of story would that be? So if you would want, according to data, to predict Game of Thrones season 8 prior to season 8, what are the variables that you would put in order to best predict the story and the conclusions?
That's a very good question.
Like who lives, who dies? That Bran is king, whatever. That was very hard.
Rather than having this complex machine learning algorithm that looks at all these different people, I'd probably make a simpler thing that looks at certain details like who is in a sort of broad conflict with who, and that starts to get you you can kind of code in that these people are probably not going to both survive. So I'd kind of try to build that on top of some of the things they have already. Obviously, whether you're noble or not, whether you're male or female, does have an impact. I think males tend to die a lot more in the show. One thing I noticed is that they've got a lot of characters they're making predictions for that you don't even know if they lived or not because they haven't shown up since like season 4.
Oh.
They had one of the ones they made a prediction for was Shagga. Shagga, the Mountain Clan guy from season 1. He hasn't shown up after season 1. There's one particular character that we never find out, and when I read it, I was like, hang on, we should have found out that. So Ilan Payne, the man who chopped off Ned Stark's head, he's a Lannister bannerman, right? He definitely should have been in King's Landing, probably, but we never got that. I would give them some credit on that and say that when you consider that when everybody was being killed in King's Landing, they're obviously trying to make a point that this was not a good thing. So if you had a character we wanted to see die in there, I guess that would kind of muddle what they were going for. Although the other way you could look at that is that, well, that would be more nuanced and interesting.
So Varys 3%, Euron Greyjoy had a 0% chance of dying. 0.
Did he?
0.
Yeah, well, so much for that. I could have sworn there were none under 1%.
So can you break down what kind of data they put in for that? That's really weird. How could he survive? Like be so certain that he would survive? If you scroll down, they actually do go over those factors, and I'm having a look at it now. And the big factor that's given them that is that apparently people from House Greyjoy, if you're thinking before season 8, people from House Greyjoy have not died very often. I think there was the Balon, who obviously, Euron threw him over the bridge. I think that was it, as far as named Greyjoy characters or even Iron Islander characters. But how is that relevant?
Yeah, well, that's one of the flaws of this model, is that it looks at that and says, oh, nobody's died from this house, so we're just going to give him a 0% chance of dying, which, obviously these are factors that are going to change in the future. You wouldn't accept that just because no one's died from this house yet, that no one's ever going to.
This is a theme that something that I find very frustrating on many, many, many levels. On when people are trying to make predictions and projections about the future, mainly I guess in politics, they just assume that if something happened one way in the past, then it will necessarily happen again in the future, which is obviously, it cannot happen again the same way. It can happen in a similar way. But it's just like, no, remember in the last elections we had this and that here in Israel, this is what happened. So now in these elections, this will happen again. Why are you assuming? So they just put their own fallacies into this machine learning thing.
Yeah, that's the fatal flaw in a lot of models.
Right.
There's varying degrees of it. Sometimes, a single factor like that, it's, terrible to assume that things will continue like that. Sometimes people put too many factors together and get into something called overfitting. So overfitting is when you try to fit your model too much to the data of the past. When you look at the data of the past and say, this is how it'll be. And then you just assume in the future it will, but then it breaks down because the future looks different from the past. There are patterns that you try to find that give you a bit of predictive power, but you need to understand that the past and the future are going to look very different in a lot of ways.
Yeah.
So there's this balance to find when you're creating a predictive model. You have to, you want to build in enough factors that you're actually getting somewhere, but you definitely don't want to put too many because then you get into the overfitting problem.
So, first of all, you have to understand the story because the characters are not separate from the story. Which character lives and which character dies is a direct result of where the story is going and what the world is like in that story. Obviously, if the story is going one way towards change, which it wasn't the change that I anticipated, but it was some kind of change, similar in some ways that the monarch was voted in and stuff. If you assume that after 8 years, the realm has to be different than the way we met it at the beginning, so you have to, from that, extrapolate, okay, so the people who will not be able to adapt and have no place and do not symbolize anything that is different, then I would increase their odds of dying. It really seems to me like the people who did this website and this thing, they're just not very good at understanding stories.
I do want to sort of defend these people.
Okay, go ahead.
I think these people probably did as good as they could, given the limitations we have on like the technology and the kinds of modeling techniques we've currently uncovered. I think if I tried to do a better job, I would probably struggle greatly and ultimately fail. All of these things that we understand, you have to take into account. It's, we understand them using our human brains, but for computers, it's way difficult to sort of translate that in a way that the computer can work with.
Okay, because it's not, you can't put it into bits and ones and zeros and Excel sheets and stuff.
Yeah. Like a good example is image recognition, which we actually are getting pretty decent at it now, but this has been a huge problem for a long time because we look at a tree and we just say that's a tree. It's very easy, but you try to think how you're going to put that into bits and bytes and explain to a computer. You're looking at it from different angles. Like you take a photo of a tree from different angles, and each photo is completely different in terms of like every single pixel. There's some stuff that it's easy for us to just look at it and go, oh yeah, there's this brown bark and green leaves, but
yeah,
you try to get a computer to understand it, and it's this incredibly complex thing.
Which is why in all these captcha things,
yes,
you have click the pictures of roads.
Yeah, Google's building up a huge data set to train these models because there's no easy way to tell it's self-driving cars what a stop sign is. It's got to look at to find its own patterns.
And is that related to the chess computers where a couple of years ago they switched things up? There was a new computer who didn't try to overthink you in terms of all the possibilities because it knows the rules, and then it can calculate whatever, a billion possibilities in a nanosecond, whatever. I'm obviously exaggerating, and instead all the data that they put in was like an endless number of past games.
Yeah, it's a very similar technique because chess is one of those games that, technically speaking, you absolutely could perfectly solve it by looking into, every single possibility. But we don't have the computing power to handle that right now. If we tried to get a chess AI to look at every single possible outcome, it would basically take like 10 million years to make a move. Wow. So instead, we have to do stuff like that, is feed it past games and make it kind of choose from that what seems to be like a good move to make in a certain situation. So there's a lot of complexity going on from the fact that we just don't have the processing power to do it the relatively simple way.
And then some of the moves that computer did based on past games were all kinds of moves that no one has ever done before, and it's like a common assumption that those will be shitty moves, like
yes.
Like did you see like the top right pawn just start with a whatever is it H, right, H2 to H4, whatever it is, the one to the right. Nobody would ever start a game with just like the random pawn at the far right end. So that gives maybe an indication about our traditions, how our traditions sometimes inhibit us, and here the computer has an advantage where it won't be, won't feel shame or embarrassment of just starting a game in a bizarre way and having the player on the other side just look at you and say, "What the fuck are you doing?"
Yeah, that's one of the cool things about these. They do come up with like moves to make that nobody would ever think to make, and it's one of the kind of mysterious things about machine learning is that it doesn't give us like a function we can read that says, "Oh, okay, if this happens, you're going to do this." Instead, it's this incredibly complex process that no human can comprehend. You just have to watch what it does, and sometimes it does things you've never seen before, and then it ends up working even though it doesn't look like it should. And yeah, there's no way we can really figure out why it does what it does.
Why can't we, if we designed the machine?
Because it's just the decision-making process it has is just so complex. So often they'll be using neural networks. So what happens with a neural network is that you have all these nodes that represent like different values. You might put in like, okay, where is this particular knight or whatever. I'm not sure exactly what they put in for chess, but it starts with these inputs that are very easy for us to read, and we understand them. But then it goes on, like from that, it passes this data on to these layers of nodes where, like, it'll start with maybe 20 input variables, but then it'll transition those across to like 100 nodes, and then start doing all these strange, complex mathematical equations that you can't really make anything of. Like, there's hundreds of them going on, and then it just, in the end, spits out a value. I don't know if I'm explaining it very well, but yeah, essentially, like, it just does a lot of math operations, lots and lots and lots of them, more than you can reasonably look at and make sense of. And it just somehow works because we get it to just keep tweaking and tweaking and tweaking in small ways until eventually it gets to a point that happens to work for whatever reason.
Yeah. And I guess chess is easier than stories because even though you would say it would take 10 million years, the possibilities are still limited. You have only a limited number of moves you can make.
Yeah, chess is very easy to sort of deduce into, these are the possibilities. There's only a very set number of them, and it's not a huge amount. From any given game state, it's like, okay, there's this many pieces and they can each do this, and that's that.
Yeah, but if you're trying to predict a story, theoretically, Sansa can eat Tyrion's face, or she
Yes.
can ride a dragon, or whatever. All kinds of things can happen that a human would immediately know that doesn't make sense. So
Yeah,
I guess
Sansa might declare herself Queen of the North, or she might, find Tyrion and declare her love for him, get back together, and then kill him in his sleep and bake his face into a lemon cake. We don't know what's going to happen. There's technically infinite possibilities.
Yeah, they could start a band together. Who knows?
Yeah,
Who knows?
they could run off and become mamas and bravas.
So I guess we're still a bit far away from computer-generated stories. I guess.
Yeah, I think so. I'm having a think about that. There might possibly be. I don't think we'd get anything comprehensible yet. I think they're starting to do like computer-generated music.
Right, I've heard about that. I heard that it's good.
Yeah, I think there was a computer-generated like a screenplay or something, which came out a bit nonsensical but amusing. Yeah, there's a lot of crazy things happening.
I read in Yuval Noah Harari, the Israeli historian who sold millions and millions of copies. Have you heard about him? He wrote *Sapiens*, and then about the past, about the future, whatever. So he wrote, and now he's in hot water because in his translation to Russian from his book, he changed a few things that were unflattering towards Putin, and he changed that to be unflattering towards Trump. And now he's in hot water on that, and I say rightfully so. So anyways, in his second book he wrote, and I didn't even finish his second book because it was a little bit annoying, he wrote that they did this experiment where they had a crowd listen to 3 different classical music, whatever, recitals, whatever you want to call it, pieces, and they asked them to try and guess which one was done by a computer, which one by a human, and most people couldn't tell which one was which. But also classical music, maybe it's a little bit more mathematical in some way than different kinds of music. If you look at like YouTube videos of visualization of all kinds of classical music, I actually encourage you to look for whatever Beethoven's 9th or 5th, and you see it looks super mathematical.
I certainly don't know enough about music to really comment on which styles are more mathematical. Perhaps classical is.
I'm not an expert also on classical music. If anybody listening wants to correct me, I'm open to that. Okay, so Mitchell, thank you very much. We also had a fun little conversation off the air. And did you have a good time?
I had a fantastic time. Thank you for having me on. Nice. I hope everybody found the stuff we talked about interesting.
Definitely. And at the end of the day, there was nothing to worry about. Come on. Everybody's worried. And then it goes fine.
Yeah, I think I was nervous early into this, but it was a good time.
I don't think anybody noticed that you were nervous anyways. So thank you, Mitchell, and thank you, everybody, for listening in. And we'll see you all next time. Bye, everybody.
Bye, everybody.